This is the Things conference. So a lot of what I'm going to say to you is probably heresy, because it's not really about the things at all. Well, it is, but not really. So a little bit of background about how it started, at least for me, was with this thing called Project Sunspot back in 2003. It was the first 32-bit IoT developer platform. Came out of Sun Labs. We can all have a moment of silence for Sun Microsystems. Relied on 802.15.4. We had IPv6 and a full IPv6 mesh on it way back then. But there was really no way to store the data. We could get data off of it, but we weren't really storing it anywhere. Next came Arduino. They were 8 or 16-bit MCUs, so not all that capable. The early ones had no networking at all. And that came out in about 2007. So we went from sort of 32-bit with full networking to 8 or 16-bit with no networking. And then we moved into various protocols, right? Various protocols came about at different times. You'll notice that the last one that's come about is LoRaWAN, right? We've gone from 802.11, which is Wi-Fi, as we know, to 802.15.4, and then we put a little bit of stuff on top of that and called it Zigbee. And then we went to BLE, low energy Bluetooth. That wasn't until 2004, and then most recently we get to where we are now with the explosion of LoRaWAN. So in the beginning, it was all about the things, right? We had developer kits, we had all sorts of things, and it was all about building things. It was the Internet of Things, and we're going to build lots of things, and we're going to put them everywhere, and we're going to collect lots and lots of things, right? And data, for the large part, was secondary. I would ask people, what are you doing with the data? And it was usually some form of mumbling with the word analytics thrown in somewhere and more mumbling, because there really wasn't a great solution for what we do with all of this data. Plus, we were much more focused on the things themselves. But why are we doing this whole thing anyway, right? We're doing this to collect data. Those things we're putting out there are collecting data. They're taking sensor readings. They're giving temperature. They're giving GPS heading. They're giving you the pressure or CO2 readings or whatever gas readings you're doing. So they're collecting data, and we need to be able to collect that data and then react to the data. Right? There's no point in collecting data that you're not going to actually do anything with. If you're not doing something with your data, why are you collecting it? Other than to just increase your storage costs. We're doing this so that we can model systems. We can do things like build digital twins so that we don't have to tweak the various things on a jet engine while I'm on the plane. We can build a digital twin of that jet engine, and we can tweak those things in software, and I feel better when I'm flying. Right? So that's what we're doing with the data. And that's why the data is actually probably more important than the things. But we're talking billions of things, right? Depends on who you ask and what day of the week and which analyst you ask. It's going to be 20 billion things by 2020. It's going to be 100 billion things by 2025. It's going to be 50 billion things by 2022. It really depends on the analyst you ask and how you ask the question and which day of the week, right? But it's still typically all about the things. And if you're somebody who's exhibiting here and you're building things, this is really important because you're making money off of each thing that's built. But as developers and as systems designers and customers, are we really focused on the things? Should we really be focused on the things, or should we be focused on the data? So all the things, right? This chart says we'll be at 75 billion things by 2025. Random chart from random analyst. That's a lot of things. That's a lot of stuff to deploy. And we've got vendors out here who will help you build those things and deploy those things all over the place. All the things, everywhere. But again, it's about the data. It needs to be about the data, not the thing. So let's do a little bit of simple math. Let's say 75 billion things, right? Now, I have a Things Network connected LoRa device that sends about 14 bytes of data every 30 seconds. So I rounded down to 10 bytes of data. Every minute will round up, of every hour of every day. This is the thing about things that we connect to the Internet of Things. Typically, once we turn them on, we never turn them off. They start sending data from the minute you turn them on, and if you're lucky, they send data forever. So once you turn it on, you better have a way to capture that data and deal with that data end to end, or you're going to be in a lot of trouble. Right? So that's 750 gigabytes per minute of every day. All day, every day. That's a petabyte a day. That's a lot of data. Right? And again, we're not just looking at one day. We're looking at forever and growing, because we're taking this 75 billion devices that may be connected by 2025, and that will keep increasing. That will keep increasing every day, and so these numbers of the amount of data that we're sending will keep increasing every day. You probably saw in the opening keynote the, 9 billion messages a year on the Things Network. That number's not going down. That number will only go up. And each of those messages contains a payload, and all of that payload is data that you should care about. And you can do your own math of how this stacks up. So it really isn't about the things anymore. It's about the data. It's about collecting the data. It's about analyzing the data, interpreting the data, storing the data, expiring the data, and removing the data. Yes, removing the data, because you don't necessarily need to keep all the data forever, do you? Do I, as a business owner, care about what the temperature was in that freezer 6 years ago on a 30-second granularity level? I hope not. If I do, I'm probably doing something wrong with my data. So I need a way to downsample my data. I need a way to expire data that I no longer care about. What I'm really the most interested in, or should be the most interested in, is the data that's happening now, so that I can make business decisions now based on the incoming data now, right? And I can look back at a certain window of that data for historical purposes and see what the trends were and where I may need to adjust going forward. But I don't need 1 second, millisecond, even minute granularity from years ago that will most likely not inform my business decisions of today as much as the instantaneous data that I'm collecting now will. I told you it was heresy. So it's about managing the data. It's all about how I manage my data. It's about how big an issue data will become, because data will become a big issue for you if you have any size of IoT deployment. You will see your data collection start to explode. You will see your storage costs start to explode. You will see all of this begin to grow and typically start to grow more exponentially than linearly. And all of that has cost. And so managing that is going to be key to the success of any IoT deployment. Remember, if we're talking about the entire IoT ecosystems, we're talking about a petabyte of data a day. Disk manufacturers are going to love the IoT. People who pay those storage costs are not, especially if you're not expiring your data and managing your data correctly. So it's data first and things second. Data first. When I'm doing an IoT deployment, when I'm trying to decide how I want to do this deployment, I recommend starting backwards. Not starting with what things I want to put out in the world, but starting with what answers am I looking for from my data? What sorts of business decisions do I need to make based on the data that I will collect? Once I know what sort of answers I'm looking for from my IoT deployment, then I can start designing what sorts of things I need to deploy, right? I can start looking at how I'm going to manage that data, and finally, the last part is what things I deploy and what measurements I need to take and how I need to store those measurements. How long do I need to store them for? How many do I need to store? And even, do I really need to store that value, right? If there's a value that I can infer from existing data, then I probably don't need to store that data point. I'll use the example that I have been playing with recently of, I don't know if it's a thing here, but in the US it certainly is. It's called the heat index, right? The weatherman comes on TV and says it's 98 degrees, but it feels like 102. That's calculated from the temperature and the humidity. So do I need to store the heat index as a value in the database? Or do I only need to store the temperature and the humidity? If I store the temperature and the humidity, I can always find out the heat index. So I probably don't need to store that. And it may be only one small data point that I'm saving storage for, but as we've seen, as we store more data, it begins to explode. So I look at what answers I'm looking for, how I can get those answers from my data, and then what sensors and what things do I need to deploy in order to get the data that I need to make those decisions. Remember, it's about the data and not the things. And I know that's heresy at a conference that is all about the things. All the vendors out there that are selling you things want it to be about the things. And it does need to be about those devices and those sensors and how those sensors collect their data and what kinds of measurements they take and what kind of measurements they send and where they send them. That's very important. But remember, what we're talking about is what those measurements are and where you send them and how you interpret them, right? I've been saying this for probably 15 years now, but data must be actionable in order to be useful. If I'm collecting a temperature value and I never use it, why am I collecting it? And I use the example often of collecting vibrational data. We discovered this thing quite by accident many years ago of putting a vibration sensor on a disk drive. And we started to notice that when a disk failed, if we looked back at the data, we could see that the vibration started to go a little off, usually about 7 days before the disk died. And so we began to call the IT department and say, got a disk that's going to die in that box in about 7 days. And they said, everything's fine. Diagnostics say everything is fine. 5 days later, their disk died. About the third time we did that, They said, how do you know this? And we told them. And they started gathering that data and using that data to make decisions so that they could go replace that disk before it died and it was catastrophic rather than afterwards. So if all I'm doing is using my data to look back to see what happened, it's not actionable. I need to start using that data to see what's happening now and what's going to happen next based on my data. That's actionable data. And if your data is not actionable, why are you collecting it? Unless you just want to pay storage cost on data that you're not doing anything with. So I always recommend, again, start with what answers I want, which will tell me what to collect, how to collect it, and what actions I will take based on it. So I have a clear path from the collection point to the decision I will make from that collection point, from that data. And if I don't have that, I need to probably question why I'm doing this. Why am I collecting this? Something like 60% of IoT deployments fail within a year. Most likely the reason they fail is because they just started collecting stuff without deciding what they were going to do with it once they started collecting it. If you decide ahead of time what you're going to do with your data and how you're going to use it to make informed business decisions going forward, you're much more likely to have a successful deployment. And that's why I say it's not the Internet of Things. And why this is heresy, it's not the Internet of Things, it's the Internet of Data. It really is about the data and not the things. You can't get the data without the things, but it's about the data because it's about what you're going to do based on those things that you have deployed. This is where you can find me on Twitter. That URL is where the slides from this talk and others will be. I haven't put them there yet, but I will do that immediately after this talk. So if you're interested in these slides, if you have further questions that I can't answer here, I'm happy to answer them on Twitter. Thank you very much.
Thank you, David. Are you taking questions or not?
Sure, I'll take questions.
Oh, okay. Yeah, so from now on it will be data first. Is there somebody who wouldn't agree? No. Any other questions are most welcome. Yes, over there. I'll come over you. Hello.
Thank you for your presentation. I can't agree more with the statements made. A question or a remark I hear often is, let's collect and store all the data from all the sensors that we can get our hands on for exploratory data science purposes. And there you get into the trap of collect everything, but not knowing what the end result will be. Even collecting it for years, you might later find out an algorithm or a machine learning approach where the data could come in useful. What's your answer to that situation? Thank you.
If you are a data scientist who is just interested in studying data, that's a great approach. If, on the other hand, you're a business that wants to make critical business decisions based on data, that's a terrible approach, right? The previous talk about cold chain monitoring, right? That's the kind of thing where you want to be able to make decisions fairly immediately based on incoming data, right? And so deciding what those decisions are and not just collecting everything. The other side of that is that if you're just going to collect everything, there are ways to manage that data so that you don't have infinite cost or unbounded cost. And one of the ways to do that is what we call data downsampling. So I may collect a temperature reading once a second, and that's really important for today. But if I'm going to look back at last week's data, I really don't need to know what it is every second. What I need to know is what's the overall trend of the data. So maybe I'll downsample that to a 5-minute average, right? And if I'm looking back 6 months ago, I really don't care what it is every second. I really only need to know what the overall curve of the data is. And so I can downsample that further to maybe a 30-minute average. And here's the weird thing about data. I can sample my data. I can see my data curve looks like this. And I can sample it I can downsample to 10-minute averages. And the curve will look the same, roughly. And here's the really weird thing. I can take a random sample of that data, and the curve will look roughly the same. So do I really need to store every single data point of every single second? Probably not. And I can save enormous amounts of money by not storing it. And that's where the calculation comes in, is what's my storage budget? How much do I want to pay to store all this data?
Thank you. Any other questions? Does that suffice your answer? Yeah, okay. Any other questions? Yeah, over there. Excuse me. Hello.
Hey, I agree with the previous speaker, actually, and probably just a further augmentation of that. Like, one of the things that data gives us is insight, right? So I think there's certainly a percentage of people that will know what they want to get from the data. But there is a very large amount of people that want to get insight from the data as well, which they might know absolutely no, but they want to see, say, correlations between temperature and behavior or what it might be. So there's no doubt we're collecting too much data, but I think we have to be open to that element of not absolutely knowing what we're going to get from it in the first place. I don't know whether you'd agree with that or not.
I do actually agree with that, to a point, right? If I'm collecting data that is not necessarily have anything to do with what I'm actually trying to decide upon, maybe not. But there are always ways to discover things that you didn't know. And I'll give you an example. I was sitting in my office one day, and I have sensors all over my desk because I build them all the time, and I'm collecting the data, and I'm looking at a graph, and I'm collecting the temperature and the pressure and the humidity and various other things. And I noticed as I'm sitting there that it got very dark outside, and the pressure started to drop very rapidly. And about 15 minutes later, my wife yelled upstairs and said, did you know that there's a tornado going by about half a mile away? It's like, no, but I do now. And I now know what that pressure drop meant. And as I was looking at that graph, I noticed that the temperature was doing this. It was going up and down in about a 2-degree range. And as I'm sitting at my desk wondering, why is the temperature going up and down at regular intervals at a 2-degree range? My feet started getting cold because the air conditioner turned on and the temperature dropped. And what I realized was that my thermostat has a 2-degree range. And if temperature gets down to this, the air conditioning gets up to this, air conditioning kicks on and it drops it down to this, and then it turns off. And then it goes back up and it turns. I didn't have to actually instrument my air conditioner. All I had to do was instrument the pressure, and I could know when it was coming on and going off. So yes, I can learn things about my data that weren't necessarily directly instrumented, and that may teach me something that, okay, now I need to go instrument the air conditioner to see what it's actually doing, but I can infer a lot of that from other data.
Does that answer your question? Actually? Yes, please elaborate.
Kind of, but I would still challenge you on insight. So insight is like, oh my God, I didn't realize there was a correlation between, say, behavior and temperature or whatever, right? Because I think one of the great revelations in data over the last decade is that we've discovered things that were connected to other things that we just didn't see a correlation to, because humans weren't good at that, but machines are very good at. So that's kind of where I would challenge you. Whereas I absolutely agree we're overdoing it. I just think we have to be open to the things that it can tell us that we previously don't know, basically.
And we do. I think as business people, we also need to be aware that everything has a cost. And as IoT implementers, we sometimes forget that everything has a cost. We'll just send the data to the cloud. Somebody's paying that cloud bill, right? And the more data we send there that we're not actually getting value from, the more it's going to cost. And at some point, there's a trade-off, and we just need to be at least conscious of that trade-off and how we collect that data and what we're using it for. And all right, we've been collecting it for a year and a half, and we really haven't learned anything yet. Maybe we should stop collecting it, right? Yeah.
Okay, thank you for that.
Thank you.
Any other questions, remarks, theories, jokes, anything you would like to share with us? Yes.
I'm always open to jokes.
Yes, yes. You got a good one? No, just a question. Please stand up.
Hello, and thanks for your talk. Just wondering if you have some kind of strategy to downsample your data other than just making averages of equidistant time things. So you basically see, okay, there's a long time nothing is happening, so I need only a few points, and then there is some very hefty thing happening, and then I need more points. Do you have some kind of algorithms that you could compress it in a database so you have the real behavior captured in a sensible way?
Yes, I do. I've managed to give this whole talk and not talk about InfluxData the whole time. So I'll pat myself on the back. But InfluxDB has a lot of these things built in. Things like expiring data so that data just automatically falls off. Things like data downsampling are built in, things you can do. Then you can do other things like if I am collecting data and I alert on a certain event, then I can have the data, the alert saved, and the data on, say, a 5-minute window on either side of that alert saved. Because I don't want to downsample that data. Because I want to know that I can go back and say what was going on before that happened, right? What was going on all these other sensors as well before that event happened, so I can try to diagnose what caused that. Especially if it keeps happening. Then I can go back and I can look at those slices of data around that and figure out what was going on right before it, and then the alarm happened, and then what was going on right after it. So that I have a better picture of, again, I can build basically pictures from my data of what caused this event to happen. And it may not have been the first thing that happened right before the alarm went off. It may have been a cascading failure that this compressor started to go, which caused this to start to go, which blew this relay, which caused the temperature to spike. And if all I'm doing is looking at the temperature, then yeah, it spiked, but I don't know what happened before that. So we do have a lot of those things built into the database to be able to do that, to save those kinds of data. So that's my only product part of the talk. Thank you.
Yeah, so to cut down data, you both summarize as well sample.
Yes.
Any other questions or remarks? 3, 2, 1. Thank you very much.
Thank you.
David Simmons.